Cheerio to you there. Hoping you're having a good day. Having a fairly alright evening. We are in swole. Wow, what kind of word is that? We're in full swing here of solving linear systems with by using linear combinations here. Um, just a quick thought here before we get rolling is a quote that I like to tell people, and the quote says that tough times don't last, but tough people do. So if we remember that here with linear combinations, we should get some things figured out, and remember that linear combinations might seem tough, but at one point they will become easier, and you will still be just as tough as you always were. You'll be as strong as you always were. So um, went forward too soon. Um, like the bottom line here says, practice problems. These are practice problems. Okay, I've already showed you a video on linear combinations, and now I'm giving you this video here on 9 problems of linear combinations, solving a system of linear equations by using linear combinations. There are a few examples in here that I didn't cover on the last video. So you probably need to make sure you watch all these, because I think we get into some that have parallel lines where they're not going to intersect, where these two equations won't intersect, so there won't be an answer. And I think we're going to maybe get into one where they are the same exact line. So if we and then you should see what that looks like. So we have 9 problems here. I didn't really mix them up a whole lot. I think this is the only one mixed up where, like terms are not lined up. It looks like this one is also that way. But for the most part, I think all of them have like terms lined up. So make sure you always remember to line up like terms. You might get in the habit of not doing that with this video, but with the other practice problems you've done, you should that should be one of the first things you always look at. Okay, well, what you can do this one of 2 ways. You can work out all 9 problems and then check your solutions after you're finished. I would recommend doing problem number 1 and then, watching the solution worked out. My method of solving this system of linear equations might not exactly match yours, but in the very end, our answers should match up. So if I do something a little bit differently than you do something, in the end, it should all work out the same. We should still get the same values for x and y, or whatever variables we're using. I would do one problem, watch the video, make sure you got it right, and then move on to the next problem. Here's the 9 questions we're going to be doing. I don't know if you want to write them down, but they're also at the beginning of every page. So if you just want to pause the video and write them down at the beginning of every page, you can do that. Well, without further delay, let's go ahead and get rolling. We'll get on trucking here. Here's number 1. This one's already lined up for us, and we're good to go here on coefficients. You have a positive 3 and you have a negative 3, so we're good to go there. We can go ahead and just add, those together. 3x plus 2x is 5x. The y's cancel out, so 5x is equal to 6 plus 4 is 10. To get x by itself, you divide each side by 5, so x is equal to 2. So we put 2 in for the x value. You pick an equation, either the top one or the bottom one. I'm just going to pick the top one. And we're going to substitute 2 in there for x. So I should say 3 times 2 plus 3y. X is 2. It gets plugged in there for x. So we're going to get 6 plus 3y is equal to 6. Subtract 6 from both sides. The 6's cancel. So 3y is equal to 0. And we need to get y by itself, which the answer here should be known to you fairly quickly. Y would be equal to 0. 2, 0 is the solution to the system of linear equations. 2, 0 is the point in which these two lines are going to intersect. Now, you may question and say, well, how do I know that's the correct answer? Well, go ahead and plug 2, 0 in for x and y. I need to plug 0 in for y. Is it equal to 6? Well, 3 times 2 is 6, plus 0. Yes, it is equal to 6. And then also, plug it into the bottom equation. It's minus 3 times 0. Is that equal to 4? And we know negative 3 times 0 is 0. 2 times 2 is 4. So yes, 4 is equal to 4. So that's how you can check your solutions to make sure you're correct. If you're taking a test or a quiz, or you're out in the real world doing this, you can always plug them back in and check. For the solution, 2, 0. Here's number 2. You need to pause it and write it down. Go ahead and do that. I'm looking here. There's nothing that I can multiply the smaller number 2 by to get, I was going to say 3, but then again, that's 2x and that's 3y. So I need to slow down here and actually see what's going on. Let's go on the top. 2x plus 3y is equal to 15. This 3y is positive, so I'm going to write a positive 3y there. And this 5x is also positive. So I'm putting positive 5x there. And the 12, it's still there. Now I have like terms lined up above and below. Well, we need to do something here. We'll go do some work. Well, in front of the x term, you have a 2 and a 5. In front of the y term, you have a 3 and a 3. They're both positive, so we need to make one of them. Negative. I'm just making the bottom one negative. You could have made the top one if you choose. So here's the top equation again. The bottom equation. Negative 1 times 5x is negative 5x. Negative 1 times 3y is negative 3y. And negative 1 times 12 is negative 12. Now, since we have positive 3y and we have a negative 3y, we can go ahead and add those two equations together, and those cancel out. We can solve for x here. 2x minus 5x is a negative 3x. And that's equal to 15 minus 12, which is 3. Divide both sides by negative 3. X is equal to 3 divided by negative 3. Well, we know it's negative, and negative 1. Let's go back here to the equations, figure out which one we're going to use. Let's use, we can use the top one. 2x, and we found x to be negative 1. So 2x plus 3y is equal to 15. Negative 2 plus 3y is equal to 15. We're going to get y by itself, so we add 2 to both sides. 3y is equal to 17. And divide by 3. So now y is equal to 17 over 3. plug this in, -1, and the y value, 17/3. Well, got another problem here. If you need to pause it, go ahead and do that. I'm looking at the 1x, 1y. Since they're ones, it's going to be easy to, change this to a -2x or change this to a -3y. I'm probably going to go ahead and make it a -2x because 2 is smaller than multiplying by 3. And why am I multiplying by a negative? Because this 2 is positive. So let's go ahead and multiply. -2 times x is -2x. -2 times y is -2y. And -2 times 4 is -8. Do not forget to multiply that 4 out there. And I think the bottom equation stays the same. 2x plus 3y is equal to 9. And since we have a -2x and a positive 2x, we can go ahead and do some simplifying here. Add those two together. -2y plus 3y. -2 plus 3 is 1, positive 1, y. -8 plus 9, -8 plus 9, it's 1, positive 1. So y is equal to 1. Those 2's canceled out. So since y is equal to 1, we can go ahead and put a 1 in for y. Now, I'm using the top equation, x plus y. Remember, we substituted 1 in there. X plus y is equal to 4. How do you get x by itself? Subtract 1. And so x is equal to 3. X is equal to 3. Solution 3, 1 is the solution to the system of linear equations there. Here's number 4. Go ahead and pause the video, work this one out. You might get a pleasant surprise at the end. Might, I don't know, maybe get a little confused, wonder what this one is. How can the answer be the answer? If you get to that point, go ahead and hit play on the video and watch my solution. So we have 6x minus 9y is equal to 9 on top, and on bottom, 2x minus 3y equals 3. So I'm looking at the bottom numbers because they're smaller. What do I have to multiply 2x to get a 6x? And actually, I probably want the bottom, since I'm going to be multiplying the bottom by a number, I'm going to go ahead and multiply by a negative sign with the bottom. That way I can go ahead and get them to be opposite of each other. So I have to multiply 2x by -3 to get -6x, or I have to multiply -3y by -3 to get positive 9y, which is the opposite of this. So, hey, it's going to be multiplied by the same number, -3. So let's go ahead and do that. -3 times 2x, -6x. -3 times -3y. Negative times negative is a positive, and 3 times 3 is 9y. And -3 times positive 3 is -9. Now let's look at the top. 6x minus 9y. Oh yeah, look what we got here. -6x, positive 6x. So we can go ahead and simplify that out. 6x plus negative 6x is going to give us a 0x. Okay, all right. Going over here, negative 9y plus positive 9y. And negative 9 plus 9 is 0y. Hey, hey guys, we've never had that before. On the right side, 9 plus negative 9 is also 0. There's a lot of zeros here. A lot of zeros. Like I told you before, going to be a lot of confusion. Maybe. I hope not. Maybe. 0 times x is going to be 0. 0 times y is also 0. And if we have 0 plus 0, well, no, it's not a bad drawing of a car. It's not. A little headlight, a little tail light, a little muffler coming out of here, some exhaust. I'm still trying to figure out which one's the front, which one's the back. Bad drawing, bad drawing. Anyways, back to what we had. 0 plus 0 is 0. Drop down your equal sign and this. So 0 is equal to 0. There's no variables in there to work with. There's no x, there's no y. There's no way to solve for those because we've gotten rid of them. But if we look, 0 is equal to 0, right? Yeah, that's true. And if you work with a system of linear equations like this, and you get a number is equal to the same number, it could be 0 is equal to 0, it could be 4 is equal to 4, you know, negative 5 is equal to negative 5. These are all examples. There's an infinite amount of examples there that I could show you, but I don't have that much time. So if this statement is true, like we have no variables, and that statement is true, then these two lines that we started out with are going to be the same line. And you're like, how do you figure that? Well, look at the bottom equation. Actually, look at the top equation. 6x minus 9y is equal to 9. Let's divide everything by 3. So I divided everything on the left side by 3, divide everything on the right side by 3. 6 divided by 3 is 2x. Negative 9 divided by 3 is negative 3y. And 9 divided by 3 is 3. And if we look, don't those equations that I just drew those arrows to, don't they look the same? So basically, no, not basically. Those two equations we started out with are the same line. And that's what you need to say. You either say that they're the same line, so they touch at every point. The solution is every point on the lines. Something similar to that. This one might work better. Yeah, I think this one's going to work better for you. All real solutions. That's probably the mathematical term we should use. Yeah. Okie dokie, then. So we are now done with bad drawings and solving systems where all real solutions is our answer. So let's go ahead and move on. You have this one here, pretty in pink. It might look pink on your screen, I don't know. So you make sure you always slow down and look at this. I noticed that I have a y on the right side of the equal sign, a y on the left side, so they're not lined up. So we need to get these things lined up. What do we need to do? It doesn't matter. We can move the y's to the left and the numbers without a y to the right. It's going to be about the same amount of work. Let's just take this top equation. Let's not take the top equation. Yes, we will take the top equation. Are you sure you want to take the top equation? I'm debating on it. Top equation? Yes, top equation. All right. So this is what we have in the top equation. Are you sure? Yes, I'm sure. And you want to move the y on the left side and the number without the variable on the right side. So let's go ahead and move the number without the variable. So we have 3x is Canceling. You still sure you want to work with the top equation? Yeah, I'm sure. We're going to get it done. All right, we'll keep on trucking. We're going to plow through this one. 3x is equal to 7y minus 6. Now we have the number on the right side. Now we need to get that y to the left side. Opposite of a positive 7y is a negative 7y. So we have 3x minus 7y is equal to negative 6. 3x minus 7y is equal to negative 6. We're erasing this up here so that way I can have more room to work. So this top equation is, I said more room to work. This top equation, 3x minus 7y is equal to negative 6. Yes. There we go. I've just shifted this one up here. And now all this is like it never even existed. Okay, let's go ahead and bring this one over with I took a moment here because I don't want to rewrite it. X plus 2y is equal to 11. I want to go ahead and save me a moment here, save me a little bit of time here. I'm looking, 2 is positive, 7 is negative, so I'm looking, can I take a number and multiply 2 by a number to get 7? No, I can't. So that's not going to help us. But let's look at the x terms then. I have 1x, and I have 3x. Well, I can multiply 1x by 3 to get 3x, but remember they have to be opposite of each other. So I'm going to make I'm going to multiply this bottom equation by negative 1. By negative 1. So negative 1 times x is negative 1x. I'm not going to write the 1 there. Negative 1 times 2y is negative 2y, and negative 1 times 11 is going to be a negative 11. All right, so we're rocking and rolling here. We are making a lot of progress. We're doing good. Now we're to the point where we can add what did you just do? If you're looking and you're trying to figure out what I just did, that's probably a good question. I just multiplied by negative 1. I just changed the signs. It didn't help us out. 3x and negative 1x, those aren't opposite. They're opposite of each other. They're not the same leading coefficient. Hit the rewind button for a little bit there and rewind back to where, it seemed like I wasn't in such a hurry to multiply everything by negative 1. That negative 1 is sneaky little fellow. Sneak up on you every once in a while. You keep an eye on him. Okay, back to my whole thought process before. I needed that to be a negative 3x. So we're multiplying 1x by negative 3. So everything will get multiplied by the negative 3 then. Negative 3 times x, negative 3x. That looks a lot better. Looks a lot better there. And negative 3 times 2y is going to be negative 6y. And negative 3 times 11 is a negative 33. Now we're rocking and rolling. I definitely got the air guitar playing. You got the air guitar going? How about the drums? Who's on drums? Who's got the mic? Who's on the bass? Okay. Got it rocking out. Okay, stop breathing hard. Stop panting. Wipe the sweat off your forehead. We're going to move on to a little bit of math here. We'll come back to the air band in a second. I said air band, not hair band. Okay, looking here. 3x plus negative 3x will give us the 0x that we're looking for. Those cancel out. Negative 7y plus negative 6y is negative 13y. And negative 6 plus negative 33 is negative 39. 13 and 39. Those are awesome numbers to work with. Divide both sides by negative 13. So now y is equal to negative divided by negative is a positive. 39 divided by 13 is 3. Do you see what I see? Y is 3, so it goes in the right side. I'm going to use this top equation, I guess, or top equation. It's at the top of the screen. That's why I said top equation. So we have x plus 2y. Y is 3. So we're going to say x plus 2 times 3 is equal to 11. Simplify here. And how do we get x by itself? You subtract 6. So x is equal to 5. We take that and we put it into our point. And that is where those two lines that we started out with at the very beginning of the problem, where those two equations will be intersecting, is at the point 5, 3. We are a little more than halfway through this. Hopefully you're doing well on the practice problems. We're looking for you to get some sort of success out of this. That way you can move on. I think we got a lot of good things to get into after linear combinations. Just a quick thought here. Here's a quote that I read. I like this quote. The quote starts out by saying, "Never quit." I'm not for sure who said it at this point. The author to me is unknown. If you know who it is, let me know, and I'll remember that. But anyways, the quote says, "Never quit. It is the easiest cop-out in the world. Set a goal and don't quit until you attain it. When you attain it, set another goal and don't quit until you reach it. And never quit." So what it's saying is, never settle for reaching your goal. You should always set more goals and always be more successful. And that's what we're doing here. Yeah, we might have done 5 of them, and we might have got them all 5 right, but we're going to practice a little bit more on these last 4 and make sure that we're getting them perfect. And then once we're done with this, we're going to not quit in our math. We're going to move on. We're going to learn more, and that's just this one part of your life. And then after that, you move on to something else in another part of your life and set a goal for it. Don't quit until you attain it. And then once you attain it, set another goal. But never quit setting goals. Never quit reaching goals. Let's in this number 6 here, let's look at that. Let's flip some things around. Let's go ahead and subtract 16y from both sides. So we're going to have, and that's in the bottom equation. Now, what's on the right side? Well, if you have 16y minus 16y, that's 0y, and 0 times y is 0. There has to be something there. Some people will tell me, well, 16y minus 16y, that's nothing. There's nothing there. Well, if we represent that as a number, that's going to be 0. Looking up here at the first equation, 3x and 8y on the left side, 4 is on the right side of the equal sign. So let's go ahead and get the number without the variable on the right side of the equal sign by doing adding 4. So we have 6x minus 16y is equal to 42. Now this is the equation we have. So this bottom equation became 6x minus 16y, and that's equal to 42. And on the top equation, I have a 3x, which I could multiply by negative 2 to get it to be the opposite of positive 6x, or I have a negative 8y. In order to get it to be the opposite of negative 16y, I have to multiply it by negative, and then in order for 8 to become 16, multiply it by 2. So I got to multiply it by negative 2. And that was the same thing I multiplied the 3x by. So negative 2 sounds like a good number to multiply that top equation by. Negative 2 times 3x is negative 6x. Negative 2 times negative 8y is a positive 16y. And negative 2 times 4 is a negative 8. And now since we have coefficients that are the same number with opposite signs, we can go ahead and add here. Negative 6x plus 6x right here is going to leave us with 0x. 16y minus 16y is also a 0y. And negative 8 plus 42, negative 8 plus 42 I think is going to be somewhere about a 34. What say you? 34? 30, is that a 34? Yeah, okay, good, good, good. Right? You sure? Looking here, 0x becomes 0, 0y is also 0, so we have 0 plus 0, which is 0, and that's equal to 34. Awesome work. 0 is equal to 34. And you might stop, be thinking there for a minute, a little bit confused. How is 0 equal to 34? It's not. It's really not. 0 is not equal to 34. And if you look here, I'm going to erase some of this here on the left side so we can get back to our original equations. If we look here on the left side, divide everything by 16 so we can get y by itself. This bottom equation is y is equal to 6 over 16 becomes 3 over 8x, and negative 42 over 16, that's 21 over 8. Let's look at the top equation here. Let me get a different colored marker for you. 3x minus 8y is equal to 4. 3x minus 8y is equal to 4. Add 8y to both sides. We're going to try and get y by itself. Why would you want to do that if you're trying to get y by itself? You probably would want to subtract 3x. Subtract 3x. So we have negative 8y, don't forget your sign here, is equal to negative 3x, and that's a positive 4, so we put plus 4. In order to get y by itself, divide by negative 8, and you divide everything by negative 8. Cancels, so I'm going to write it over here. Y is equal to negative divided by negative, negative 3 divided by negative 8, will give us a 3/8. So we have 3/8 x, and positive 4 divided by negative 8 is going to give us a negative 1/2. And so basically what you've proven here is what we've proven right here, is that when you have two lines and they have the same slope, I just changed those to slope-intercept form, they have a slope of 3/8. When those two lines have the same slope, what is it? Come on. Same slope, different y-intercept. Those lines are going to be parallel. And that's what this means. When this says 0 is equal to 34 and you stop and you say, no, 0 is not equal to 34. Well, it's not equal to 34 because what is the whole point of solving a system of linear equations? The whole point is that you are trying to find the point where those two lines are going to intersect. And if they don't intersect, you're going to get something like this that says 0 is equal to 34. Sometimes it might say 5 is equal to 8 or negative 1 is equal to 10. If you get a false statement, and notice we have no variables, 0 is equal to 34. If you get a false statement with no variables, then the lines are going to be parallel. A couple of examples ago, we had a true statement with no variables. I think we had 0 is equal to 0. That meant that the two lines were exactly the same. So, quick heads up there. Number 9. Number 9 is one you like to see there. You have positive 12x and negative 12x. So let's just go ahead and hop on the wagon there and take a free ride. We don't have to do much work. 12x minus 12x is going to, or 12x plus negative 12x is 0x. Negative y plus positive y, 0y. And 5 plus negative 5, 0. On the left side, 0x plus 0y is going to give us 0. And on the right side, we drop down our 0. So 0 is equal to 0. All real solutions. I forgot to tell you something on the previous problem. Number 7, the one that we're working on here, is all real solutions. Number 6, the previous problem, the answer here, what you want to write down is no real solutions. Oh, shoot. Oh, wait a minute. Can I move that? Oh, no, I can't move that. Damn. No real solutions is the answer here. Okay? False statement, without variables, no real solutions. True statement, without variables, all real solutions. Means the lines are exactly the same. Here's number 10. M and P, trying to solve for M and P. Looking at the top equation, if I multiply 2m by negative 2, I'm going to get the opposite of a positive 4m. That's what I'm going to do. So multiply everything by negative 2 on the top. We have negative 2. So negative 2 times 2m, negative 4m. Negative 2 times p is a negative 2p. And negative 2 times 7 is a negative 14. Yes. The bottom equation will stay the same because negative 4m and positive 4m are opposite of each other, and they're going to cancel out. So I'm just rewriting the second equation. And from this point, since we have the same leading coefficient and they are opposite of each other, we will add them together. Negative 4m plus 4m is 0m. Those cancel out. Negative 2p plus 3p is going to give you 1p. And negative 14 plus negative 10 is a negative 24. I like the top equation up there to substitute p in. So 2m plus p, which p is negative 24, so I'm just going to write 2m minus 24. That's equal to 7. Add 24 to both sides. So now we're left with 2m. The 24s cancel. Is equal to 7 plus 24. Good job. Good job. 2m is equal to 31. Divide by 2. Divide by 2. M is equal to 31 halves. And so now your solution, 31 halves, which is 15 and a half, 15.5, however you want to think about it. Typically, we should just go ahead and leave it as an improper fraction. 31 halves, negative 24 is going to be the solution here. And that's where the two lines that we started out with, that's where they are going to cross. Okie dokie, Smokey. looking right here, and this is going to be the last one we have. So we're going to work this out. Hopefully you've learned a lot. Hopefully you either learned a lot or you have realized that you already knew how to do this and you are near perfect with this. So that way you set a new goal. We need to multiply the top equation by a number. Both the numbers in front of s and t are 1 and -1 respectively. I like getting rid of the t's because this one's a negative, this one's a positive. So all I have to do is multiply the top equation by 4, and that's going to give me a -4t on top and a positive 4t on bottom. So those are going to work real well together. So let's go ahead and do that. 4 times s is 4s. 4 times -t is -4t. And 4 times 5 is 20. The bottom equation stays the same. 3s plus 4t is equal to 16. And we have -4t, positive 4t. That's what we're looking for. Since they are opposite of each other, we can go ahead and add. 4s plus 3s is going to be a 7s. The 4t's cancel. And 20 plus 16 is 36. Oh, it's going to be an ugly one. I'm going to have to work with some fractions. It's okay, though. It's okay. Divide both sides by 7. S will be equal to 36 over 7. And remember, alphabetical order. Let me check here real quick. Yes, I put these ones in alphabetical order. If you think about the alphabet, it says M, M, N, O, P, and that's the reason why I put M first and P second. So if we come over here and we're going to make our ordered pair, if we're using S and T, we have Q, R, S, S, T. So S is 36 over 7. Oh, so we have 36 over 7. We need to plug it in for S. I'm going to plug it into the top equation there. And let's go ahead and do some work. So we have 36 over 7 plugged in for S. 36 over 7 minus T is equal to 5. Let's subtract 36 over 7. Subtract 36 over 7. Well, I will need common denominators to add these or subtract these numbers. 5 minus 36 over 7. Well, I know 5 is 5 over 1. And if I multiply the 1 by 7, I'm going to get 7 as a denominator. So if I multiply the 1 on bottom by 7, I got to multiply the 5 on top by 7, and I get 35. So now this is what I'm working with. 35 over 7 minus 36 over 7. 35 minus 36 is -1, and the denominator stays 7. And that's equal to, don't forget your negative sign in front of the t. We're going to either divide both sides by -1 or multiply both sides. I divided. T is equal to, well, -1 over 7 divided by -1. I know negative divided by negative is a positive, and I know that anytime that I have 1 on the bottom, it is just the number that's on top of the fraction. So T is equal to 1 over 7. And there we have our solution. I am not real confident that this is a solution. I'm going to go ahead and plug this back in and check it out. If it's not, I'll rework the problem for you. But if it is, then you've done good. Looks like I've done good, and so we're probably pretty good. So if you have any questions, don't hesitate to ask. Send me a message. Let me know. how it's going.